Yeah, I am 𝐒𝐿𝐴𝐲, treasurer of NSB, and it's my absolute pleasure to welcome you all to the exciting and insightful session. We are honored to have with us Mandeep Singh Sehrawat, a leading voice in cloud native system design and distributed computing. Mandeep is currently working as lead 2 software engineer as technical specialist at 𝐒𝐸DRAL, where he is building data plane compute systems for SkyTab Cloud with an impressive career spanning across SkyTab, Jupyter, and now 𝐒𝐸DRAL. He has led the design and deployment of complex cloud infrastructure and modern enterprise systems. He is also the co-author of O'Reilly book System Design on AWS, where he distills years of real-world experience into actionable insights for developers and architects across the globe. A passionate educator, Mandeep shares his expertise on YouTube through his channel MsDeep Singh, where he breaks down complex system design concepts with clarity and depth. As alumnus of the Army Institute of Technology, Pune, Mandeep is not only a full-time software engineer but also a community builder and AWS expert. His dynamic approach and genuine passion for scalable systems development have made him a trusted voice in the software in the engineering community. With his contributions to technical literature, cloud platform, and educational outreach, Mandeep Singh Sehrawat is truly shaping the next generation of system architects and engineers. Let's all extend a warm welcome to our distinguished speaker, Mandeep Singh Sehrawat. Over to you, sir.
Hey everyone, I will just enable my camera so that all you can see me. Feel free to enable yours as well. Hey everyone. So I will share my screen as well. I have created a short presentation which we will go through. Just give me a moment. Is it visible?
Yes, sir, it's visible.
Okay.
Yes, sir.
Cool. So, hey everyone, I'm Mandeep Singh, and thanks for the great introduction, Karthikeya. Today, what we are discussing is we are discussing system design essentials, and we will try to cover some of the fundamentals, and we will take a real world use case through which we will try to understand that how you like some fundamentals, and then how you actually design the systems as part of your interviews. Like many of you will be appearing for the interviews, and also like when we will be joining the company, how these fundamentals and your knowledge based on system design is useful. Okay, so the agenda will be that we grasp on the fundamentals, and we also take understanding of how actually system design is done in real world life when you actually join a company as software engineer or architect. Before we get started, a quick introduction about me. Karthik already introduced, but yeah, I'm a software engineer, as you mentioned. Also author of System Design on AWS. This QR code here is my LinkedIn profile. So you can connect with me for any questions and all. And I also regularly publish videos on YouTube channel MsDeep Singh, which again are focused on system design. And this is my book, System Design on AWS, if you guys want to check out. So let's get started with the session. We will take the, we will start with the definition of system design, what a system design is. So I remember the definition from the famous movie Three Idiots, where the professor asked the student what is a machine. Okay, and that machine definition actually applies to the system as well. A machine is anything that simplifies work or saves time, right? So that machine, if we apply not on a mechanical machine, if we apply that on a software system, that's what a software system is intended to do as well. Like whatever system we are using right now, we are using Google Meet, right? It saves our time because I'm at my home, you are sitting at your place, and we are interacting with each other, right? So it is simplifying our work. I don't need to travel because of Google Meet. So that's a great software system, right? And what design is to figure out how the system is working. So first thing is, what's the system's job? System's job is that we all are connected. How the system will work. So how you are able to hear me right now. Okay. These are the little details we have to figure out when you actually design a system. How right now I have opened my camera, so you are able to view at your end as well. So how like these bits and pieces are transferred to you. So these are the things basically we figure out as part of design. Be it any software system, the main idea stays the same, that you have to figure out what's the system's job and then the internal details of how the system will work. We also have to figure out like how, if there are multiple systems, then how they interact with each other. Okay, there can be multiple system or there can be multiple components in a system as well. So how they are interacting with each other. Okay, so this is the quick definition of system design. By the way, like for any questions, if you have any questions, feel free to ask in between, or like we will keep a quick Q&A at the end of the discussion. So you can ask them. Just keep posting on the channel, not channel, the chat window, and we will address all of them at the end of the session. Okay, so I said that we will take an example of software system. So the software system we are taking example of is Airbnb. If you haven't heard of Airbnb, it is much similar to booking.com. If you haven't heard of both of them, then it's assume that you are going somewhere and then you want to book a platform or book a room, not a platform. Book a property, basically. We will heavily use the word property. So if you are trying to book a property or a room when you go somewhere, how that system will work. Okay, so we'll try to figure out all those details, first starting from the requirements, that what is the expectation, that that's what I said, right? What is design? We have to figure out what's the job of the system, the software system, and then finally how it will work. So that's how we will be, like that's how our approach will be. So first, like what's the starting point? Whenever you are given a software, like a system design problem statement, what will be your starting point? The starting point will be identifying expectations from the system. Okay, and the expectations are basically the features which are offered by the system. For Airbnb, it is as simple as you want to book a property in a particular date range or in a particular location. Okay, so they are termed as functional requirements. Basically, what's the function of the system? So when we say, when I say what's the starting point is identification of these expectations from the system. So we are basically figuring out the functional requirements. You are figuring out what's the function of the system. So what's the function of the system? Now, if we take an example of this software system, right? There are two end users or actors you might have studied in your classes. Who are the actors for this system? So for this system, there are two actors. One is host, one is guest. So if you see these platforms, right, they are the kind of middlemen. They don't own the properties per se. Okay, they are just a middleman. So there is some owner who has listed their property on this platform, and there are guests who use this platform, see onboarded properties, and then book from those properties. So for these two actors, we have different set of requirements or different set of expectations. Now for host, the requirements are that you are able to onboard a new property, basically like after registrations and all. You are able to onboard a new property, then you are also able to manage the property. Let's say you have to add more rooms, or you have to update some facilities and all those things. Okay, so these are the expectations for the system from host perspective. Now for guest, like assume that you are a person, okay, using that platform. So what's the call flow, or what's the actual, like how you go through the platform? First thing is that you search for the properties. So you select a location, you select a date range, and then you say that you probably apply some filters, or you directly search. So in that search, you will see a list of properties. Okay, now once that onboarded properties are shown in the list, you will probably like some property, and then you will click on it. You will view the property. So that will show more details of the property. Let's say what's the actual pricing as per the room type, or what is the facilities you are getting, or like more images of the property and rooms, and like all the amenities which are there. Reviews you can check. On the search bar, you see a high level review, like let's say this property is rated 5-star. But what are the actual reviews? Like if the people stayed there, what kind of reviews are there? Once you view a property, so you search for the property, you view a property. Now you are sure that you want to book this property, so you click on that book button, you select all the options which are needed. Okay, and then finally you also need an option so that you can manage this already booked property. Manage as in, let's say you want to extend your travel, or let's say you were booked for 2 days earlier, now you want to add one more day. Okay, or let's say you want to avail some more services, earlier you didn't include spa, now you also included that extra additional service, or you didn't included lunch at that moment. So you should be able to update, and then your system should work accordingly. So there should be option for this guest to manage the properties. Okay, so these are the expectations from our system. Now if we talk about expectations around, right, we are continuing on the same. There is also a second type of requirement, and we call them non-functional requirements. So we are clear on what are the features which are expected out of the system. Okay, now we are figuring out what are some other things which we have to know. Okay, so the other things, like other kind of requirements are called non-functional requirements. We call them NFR. What NFR means, it means the constraints under which the system operates. Okay, and we will take few examples. The definition might not be clear. We will take a few examples in the next slide, which will make you more clear. And so NFR per se, right, they are not the features which are perceived by the users or end customers. Okay, but they are important to ensure the system quality, how the system is working, how the system software system is working to serve the end users. Okay, so those properties or those non-functional requirements are important that way. Let's take two examples. Like for our Airbnb system, what are some of the requirements that are important? Okay, so the first thing is, like, if you are designing a system, the system should always be able to respond to user requests. When I say respond to user requests, let's say you opened airbnb.com, you should be able to see all the things. You should be able to search, you should be able to book the property, you should be able to view the property. Okay, these things, it's generally referred as availability of the application. Like, is your application available, or like how much times a year your application goes down. So it is generally represented in percentage, and we strive for maximum availability possible. 100% definitely, it's very optimistic, but it's hard to attain that. Like very reliable services as well, which are present or like offered by clouds as well, they also don't offer 100% availability. But yeah, if we all strive for, let's say, 99.9 as well, that's pretty good. Okay, so this is the first thing. So whenever you are defining these constants, you define those values. Okay, so let's say I want my system to be highly available. Now what is the definition for me as a highly available? It could be 95% for someone, it could be 99% for someone, it could be 99.99 for someone, or like more nines. We calculate them as nines. So let's say 99.99 is 4 nines of availability. Okay, so this is one of the NFR. Another thing is, your system is working, but is it working as intended? Okay, so let's say you are searching for properties at Jaipur location. You should be getting in the search results the properties for Jaipur only. There should be not be available properties from Udaipur or like any other location, right? So if your system is working as intended, this is one of the example, and there can be many more, that your system is working as intended, how it's expected to work, it is expecting that way, and it is referred to as reliability of that application. Another thing is, like, whenever you are trying to search, you should be able to get those search results quickly, and we try to measure that via latency. Okay, now whenever you are defining these requirements, as I said, for availability, right, let's say we are saying that our application availability is 99.99. so in interviews, or like I mean, like if you are building your own systems as well, we try to define what these property mean for me. So when I say low latency, what does it mean for me? Is it 5 seconds? Is it 10 seconds? Is it 1 second? Is it in milliseconds? Okay, so I define that constant for me, that my system will operate under these constants. So if, let's say, I say my system will respond under 500 milliseconds, all the search results, if it's not responding, then I'm breaking those constants. Okay, that's how I say that my system's quality is ensured. Okay, another thing is, at any instant, you want to avoid double bookings and specifically payments. If your system is allowing to process payments, their payment should be done single, I mean, it should be a single instance only. It should not happen that I paid once but the money is deducted twice, or same goes for the bookings as well. If you have booked one room, you should be charged for one room only. It should not, the system should not say that you have booked for two rooms or something like that. Okay, so this is the NFR which we have to adhere to. Another thing is, if the booking is completed, you should see the booking as completed. Okay, and we measure that as a consistency property. Okay, if I'm trying to retrieve that result that I have like completed the booking now I am trying to view my booking status, so it should not say that payment is pending or something like that. It should show that the payment is completed. Or even if I check from, let's say, another machine, earlier I booked a particular location from my laptop, and then I'm checking the update from my phone, so it should say that it is completed and not otherwise. So this is what we say strong consistency. System should be able to support increasing demand, and what we mean by this is that you may have started small with a small scale, but as you scale, as new and new properties are onboarded, or as new and new customers are onboarded, uh, your system should be able to perform, as in it is available and it is reliable. So that we call as scalability. Your system is able to support that scale. Now, one important aspect in these NFR is the CAP theorem. You might have studied this in your college as well as part of curriculum. What CAP theorem is, I will take an example here quickly. Now, CAP theorem basically means, so CAP here stands for, C is for consistency, A is for availability, and P is for partition tolerance. Now, I already described the definition for these, right? Partition tolerance basically means your system continues to function despite network failures. And it is bound to happen, okay? The network is not reliable. You can't say that network will work. And it is one of the fallacies of distributed system, that we assume that network is always reliable. We assume that inherently, but that is not the case. The network can always break. So the point here is what CAP theorem states. It states that at a point you can only have two properties. You cannot have three of them altogether. Okay, so either your system will be CA, which is consistent available, either your system will be CP, or it will be AP. Now, whenever I say a system is CA, what we mean here is that both of them are 100%. Okay, your system is 100% consistent and your system is 100% available. But right now, like in the previous slide itself, we just said that it's really hard to get that 100% availability. Okay, so this theorem is kind of theoretical, that if you want to attain, okay, if you want to attain those properties, then how you can go about it. Cool. Now, one key thing here is that partition tolerance, we can't keep it as optional. Because if we want our system to be available, or if we want our system to be consistent, we want the network to be available in a distributed environment. Okay, so the ideal statement for this CAP theorem would be that in presence of partition tolerance, do you want to choose consistency or do you want to choose availability? Okay, so you have only these options, that you have partition tolerance as always. Either your system will be AP or either your system will be CP. Okay, cool. Now, I hope we are clear with the requirements. So that is the first step, that you are clear with the requirements, what we are trying to do. Now, the second step would be to identify. So as part of requirement, I have not covered that, but we also try to do some sort of capacity estimations. And depending on that, we try to make decisions. Like depending on the skills, our architecture varies. Cool. So that is one of the things which we try to do, but I skipped that given the audience are mostly from the college, right? Now, the second thing, like once we are clear with the requirements, once we are clear with the functional requirements, when we are clear with the non-functional requirements, the second option would be to start with the actual design, how the system will work, to figure out the internal details of the system. How does my architecture looks like? But before starting that, a few of the things I wanted to mention, that there will be no perfect design or architecture. Okay. Now, as part of college, you might be preparing for coding interviews. Okay, and you might be solving a lot of problems. So as part of algorithm problems, you are always able to figure out that, yeah, this is the best solution for this ON solution or O log n solution, right? But in case of system design, when you are architecting the systems, that's not the case. You cannot say that this is the best design for my system. Okay, there will always be trade-offs. You will always have to analyze what kind of things matters to me. Okay, and the architecture can depend on a lot of factors. First is business use case. What are your functional requirements and non-functional requirements? Now on business use case as well, see, there are a lot of booking platforms available, but the architecture is not same for them. Booking.com has different architecture, Airbnb has different architecture, Agoda has different architecture, MakeMyTrim has different architecture. Any of the booking platform has different architectures in place. Okay, they don't have the same architecture to serve the customers, but the end functionality is kind of similar, that you are able to book a property. Okay, so it heavily depends on how you perceive the business use case. Another thing is cost. So whenever you are designing system or whenever you are deploying the system, finally there is a cost associated to it. So first thing is that you need engineers, right? You have to pay them. So that's one cost. Another thing is the cloud cost, right? If your system is deployed somewhere, you have to pay the cloud provider, or if you are managing them on as well, there is a cost, right? Scale is another important factor, that what is the scale I'm trying to serve. Okay, if you look at the architecture of, let's say, Instagram right now, so the architecture right now is completely different from how it started, like in 2012 or some year that, right? So the architecture varies over the time depending on what kind of scale we are serving, because we will have to figure out, or like we have to figure like fix those bottlenecks that come on. And the things which we have to ensure is that, let's say we have said that my NFR is no latency. So if the scale has increased, am I able to ensure that low latency right now as well? Or let's say I have said that my application should be 99.99 available. So with increasing scale as well, if I'm able to support, if I'm not, then I will reevaluate my architecture and then figure out what are the more things can be done. Expertise is another important parameter whenever you are architecting a system. Just take a simple example. Let's say you have used Python as a programming language heavily. So if you, let's say, starting some startup, it would be your first choice to go with, because you already have that expertise. Or that same goes for databases as well. You have, let's say, heavily worked with MySQL or any other database. You have that tendency to use that database for your use case as well. So expertise plays a big role in what you previously worked on. Okay, and that technology you tend to use in your new architectures as well. So these are the things, and then let's get into the actual design of the system. Okay, so I said that we had those feature requirements, right? We figured out the functional requirement. So at high level, the system has mainly three components. You are able to onboard a property, you are able to search for the properties from the onboarded list, and then finally you are able to book the property. Okay, there are more details. We will just keep the site, like given the length of session is like 90 minutes or so, we will keep the discussion that way, that we are able to cover some of the fundamentals and then we are able to discuss the design as well. Okay, so these are the high level three components, that there are users, property owners or users, then they are able to onboard the property, search property, book property, and then there are some databases where the details are stored. Let's start with the first component. So what is the flow for the property onboarding? Property onboarding flow is that you are able to gather property details from the owner. So the system will gather property details, the user will be registered, and then you will get some details like let's say what's the property location, what's the property name, how many number of rooms, what's the pricing, what are the different facilities. Okay, then you save the data to database, any database which you have chosen. We will go into details there, and then finally you query on top of this data based on location and the filters, which comes as part of your search architecture. Now, as part of gathering of property details, we said that there are always trade-offs. Okay, so this is one of the example that I wanted to discuss, that whenever you are gathering the property details, there can be two approaches. There can be more, but I took two examples. First thing is that you take all the information in one go and then finally save it to DB. Let's say you provided some Google form, you gathered all the information and then now you are saving it to database. That's the first approach. Cool. Another approach could be that you take the information page by page. Okay, let's say you created multiple pages in your UI. First you added all the, let's say, property details and owner details. Once that is done, you save it to database. Then you take the details like type of property, images, and all those things. Okay, then you save that data to database. You take then pricing, and so The idea is that there are multiple pages, and then you take the information and continuously save to the database. So these are the two approaches right now. Now, think that which approach makes sense to me. I said that there will always be trade-offs, and depending on what our requirements at this moment, we will choose a particular approach. Okay, so let's discuss some of the trade-offs for both these approaches. Now, if you think of the first approach, it's pretty simple. Okay, it's easy to implement. You gave some form, you took up all the information from the property owner, and then you have some API, let's say, or probably you are saving it from Google Form to just Excel. Okay, and then you are saving to the database. Okay, so the flow is pretty simple, that you take the information, then you save it. But the problem here could be, let's say whenever you are saving this data, you gathered all the data, but whenever you are saving this data, there is some missing detail, okay, or it failed in some sort of validation. Okay, now in these kind of scenarios, you will have to ask the owner again to fill all these details, okay, because you didn't save them intermittently. Okay, so this is one of the issue. And I also created one architecture on booking.com architecture. They had the similar architecture earlier, that they used to take all the information all together, and then it was very hard to debug the failures. Okay, because it's hard for property owners as well as the engineers to figure out what actually went wrong. Cool. So the failure handling is pretty better in the second approach, because what you have is, you have some kind of workflow orchestrator. That don't go on the terms. I will suggest that you keep note of these terms, and then later you can explore more. But the idea is that you have multiple pages, and then, so think of it as a workflow, right? There is a step one, that you take the information, then you save it. So this is a workflow step one. Then you move to the second step, where you take more information and then save it. Okay, so it's a step-by-step process. But we said that the first approach is pretty simple. This approach has, you have to write some extra code to create that workflow orchestrator. Okay, and you have to save the data intermittently, or you have to run those validations in between. But it also makes customer life easier, because let's say it's failed in step 3, so you already have the details for step 1 and 2. You just ask that fix this information, and then again try for step 3. And also becomes easy for the backend engineers, that in which particular step the system is failing. Was it corrupt data, or was some issue at our end? Okay, so these are the trade-offs, and depending on them, we can just choose one approach. Okay, so if you are just starting out, first one sounds great, but if you are, let's say, operating at some scale, then second one is better. So this is the workflow, and this is the diagram I took from my book. I was lazy enough to not create the diagram again. So this is one of the chapter 18 in my book, how you design a hotel reservation system. So try to, if you want to get into more depth of this session, try to read out that chapter. You can read it via using O'Reilly free trial. So you don't have to spend any money to start with. So explore that chapter. You will find more details which will be skipping, because we also have to cover some fundamentals in this one. Okay, so this is the some sort of workflow. Okay, you have an onboarding system. It has registration. It checks if the user is registered or not. If it's not registered, then you register that user. If it's all registered, then either you are listing a new property or you are modifying existing property. In listing new property, you are probably adding some rooms or updating rooms or adding more images, facilities. It is a simple diagram, but yeah, there can be more operations on add and update. Cool. And finally, you are also at part of each step, you are saving the property details, and that's what we discussed in the workflow orchestrator. Now, we understood there is a font problem in the title, but yeah, we understood that what is the use case we are looking for, like how the system is built or how the application is working. Now we have to figure out where this data is saved. Okay, the database, right? And you might have studied as part of college curriculum that there are different kind of databases, where should they be used, and it's also a critical discussion for interviews as well, like which database you will use for your use case, why this database. So the discussion goes into depth there. Or like if you're choosing this particular database, what are the query patterns, how the data will be stored, or some schema around it. Okay, If you are choosing a particular database, what is the schema for that database, how the data will look like, how will you query this data. If the query patterns query patterns will change in future, then how your database will support that. Okay, so this is part critical discussion for interviews, and also it's part of your actual work as well. Let me quickly take a sip of water. Okay. So database, right? So we have to figure out which database, and there seems to be some issue with the font, but yeah, let's continue. So there are, at a high level, there are I mean, the database case can be categorized into, first is file-based storage. Okay, we generally don't read them as database, but you can also treat your file as a database. In my college, I created one project where I didn't use any database. I just use my files on my computer to store the data and then retrieve the data and read from them. Okay, so you can very well use the files as your database to store any information and then retrieve from it. But you might face issues at a scale. From a file-based storage, you need proper query patterns there so that you can easily retrieve the data. Another type of databases are relational databases and non-relational. So these are the like categories which you see. There are SQL and NoSQL databases, like which you see in the industry, or like which you see in the discussions, or like whatever you read on the internet as well. These are the two categories in which the databases are categorized. Okay, so if we talk about relational databases are basically your structured collection of data. Whenever I say structure, now in case of file storage, there is no basic structure which you have to adhere to. But if you are using a particular database, particular relational databases, let's say MySQL or PostgreSQL, there is a structure you have to follow. Okay, it is a combination of one or more tables. So you define your data as form of tables, and those tables, what are the different columns. Okay, you will have to define those columns, and what is the data type of those columns. Okay, what is your primary key, as in like how you uniquely identify it, column in the table. So your data is organized into one or more tables, and that table is combination of rows and columns. You see a property table and property address here. These are two of the tables I created. So you can very well address, like very well use this kind of structure. Okay, so, and there is also the tables which you create, there is some sort of relationship between them. So that's how you organize the data in relational databases, and that's how the term is coined up, relational databases. Okay, there is some relationships between different data sets or different entities which you have. So one is that, let's say, property table. So in this property table, you have property title, property address. Now this property address has more details. Okay, so that is the different table which I have, let's say, created, which has street name, pin code, and city and country and all those things. Okay, so every row can be identified by a primary key, and then it can be associated to other table with a foreign key. I'm hoping that you are already aware of these terms. If not, please read through. It's pretty important that you understand the basic concepts around them. Okay, so this is one of the example for relational databases. Now, if we talk about the database choice for property onboarding, okay, so how you see the property onboarding? If you see, like, one of the things like in our previous slide is that there is a property table and there is a property address table. Okay, so there is some sort of definitely a relation, right? And same goes for, let's say, you have a property, and then in property there are different rooms, or there are reviews which are associated with the property. So there is definitely relations which you can leverage. Okay, so this meets our basic requirement. There are definitely relations between property onboarding data. So relational databases make sense. Okay, now, but let's discuss more. How about relational databases? There is also one parameter, images. We want to store the images. Okay, and it's completely unstructured data. Like, it will be hard to store the image in your relational database. You can definitely store in the byte form, but it's not the best way to do it. Okay, the ideal way would be that you use some you leverage some sort of object storage. Okay, such as Amazon S3, or there are like Microsoft Azure. I think Blob Store is the service they offer for storing the object to be used as object store. Okay, so what you do is you store these images in object store such as Amazon S3, and then you keep reference in your database that for this particular property or for this particular room, these are the images. So you can just keep a column which says list of images. Okay, and these list of images gives you the URL of Amazon S3 where you can download them and then show them to the user. Okay, so we are clear on the images part. Now let's also discuss on the non-relational databases. Okay, so non-relational databases, as the term says, it's the databases without relational properties. And this is the general term. Like I mean, there is no standard definition for non-relational databases because they are like really like multiple types of them. Okay, and then each of them serves different use cases. Cool. So if you talk about few of the examples, one is key value database. Okay, DynamoDB is one of the example that you have key and corresponding that to that key you have value. Okay. Then there is document databases. Example is MongoDB. Okay. Then there are graph databases. Graph databases you can say is the extended version of relational databases. There are relations, but at a very large scale. Okay. Let's say you want to manage the connections for your LinkedIn profile. So how you are able to manage those mutual connections? So they are maintained in the graph database. LinkedIn has their proprietary solution, but yeah, Neo4j is one of the example. Then there are time series databases. Let's say you want to capture the events time wise. There are some metrics or some sort of things. Okay, so for those use cases, InfluxDB is one of the use case. Then there are text search. Okay, you are searching for something, fuzzy search and all those things. Elasticsearch or open search is one of the example. So these are few of the examples. There are more such as like columnar databases. Cassandra is one of the example. So these are the like pretty what you say some of the examples, and there are more, as I said. So there is no standard definition for non-relational databases, but what if the relational database is not relational, then we categorize it as non-relational. Okay, so this is, I mean, a use case. What you say, this is the diagram. I took it from the book. So this is the workflow. Like you can use it to decide or like take some reference that how you can decide which database makes sense to me. Okay, so the first thing is you figure out what's your data type, how does your data look like, is it structured, is it unstructured, is it semi-structured. Okay, so for our use case, property onboarding, right? So it was structured, so we try to create those tables, property and property address. Okay, it could be semi-structured or it could be unstructured like images. So for those we leverage object storage. Cool. Now for structured, there can be two use cases. Okay, one is transaction OLTP, another could be analytics OLAP. Okay, so these are two of the types. I'm pretty sure that you studied them in your college. For OLTP use relational databases, and for OLAP use columnar database. Okay, now for semi-structured, these are some of the examples that what are the different databases you can use. Okay, we already discussed this, that if there are entity relationships or like connections kind of use case, then you use graph database. If it's a dictionary sort of thing, then you use key value database. In case of key value, it could be either in memory or not memory. So for caching use cases, we will also explore like what cache is and how caching is done. But for caching use cases, we leverage databases as Redis or like the in-memory databases, basically with where they are much faster to operate because data is saved in memory instead of disk. Okay, this is one of the diagram which you can take it as reference, but don't treat it as a source of truth. Okay, so it's a heavy disclaimer whenever you are choosing a particular database. Okay, there is no standard way of choosing a database. As I said, right, in system design there are always trade-offs. So don't treat this database choice diagram as the only way to make your database decisions. Okay, your database decisions will be combination of lot of factors. Okay, first thing is that it meets your use case. That's the first thing, it has to. Otherwise there will be no point in using the database, because in the end we have to meet functional requirements and the non-functional requirements. So the database choice has to meet the use case. Another thing is you have to figure out the access patterns. Depending on the access patterns, your choice will vary heavily, and they will decide how your database schema looks like. So first you figure out what are your access patterns, like how you will store the data, how you will read the data. Okay, so for if I take an example of access pattern, it could be as simple as like give me all the properties for Jaipur location. Okay, so that is one of my access pattern, that give me all the properties based on location. There could be other filters, give me all the properties for Jaipur location which are 5-star rated. Okay, so these are the some of the use cases which you have to figure out, and based on those use cases you will figure out which database choice makes sense to me. Expertise is another important factor. We already discussed this, that if you are already have some expertise in one of the database, you tend to use that because it's easy to use and you already have experience how it works, and you identify all the edge cases, so you know the best way around it. Cost is another factor. So there are a lot of databases. There are like open source use databases which are available. You can install them, you can use them. There are databases offering which are available by cloud providers, and there are a lot of companies which are created specifically on top of these database offerings. 𝐒𝐲𝐬𝐿 is one of the use case, right? There are a lot of use cases, and I mean lot of companies which offer these databases. Okay, so you have to figure out what is the cost you can bear. Okay, and another thing is operational overhead. What when I say operational overhead, this is one of the important parameters when you choose a particular technology in your system design discussion. Now, what I mean by operational overhead is like whenever you are choosing a solution. Okay, let's say you installed MySQL from open source and then you install on the laptop. Now let's say some vulnerability comes in. Okay, so you have to fix that bug, so that operational overhead is on your own hand. Okay, on calls, if you have heard of the term, in companies there are on calls, right? So there is an operational overhead associated to it, but if it's managed by a cloud provider, you don't have to worry about those vulnerabilities. Okay, they are automatically taken care of by that company. Okay, so you took that extra load from your end to and given that to the company. Okay, but you have to pay the extra cost for that. So you have to keep that fine balance. What is the cost you can bear and what is the operational overhead you can bear. Operational overhead is also a cost because you have to pay the engineer to manage those. Okay, so and like these days there is very thin line between what relational databases is like what they are offering and what non-relational database are offering. Okay, non-relational database, like in the earlier days, they were known for like they can support ever increasing data sizes. Okay, so they were started off with requirements with big data, Hadoop and all those, HBase, Hadoop, all those things, right? But these days you will see a lot of offerings and they're intermingled. Okay, so one of the examples is Aurora 𝐷SQL. This is one of the databases, relational databases, which is offered by Amazon AWS, and it is a relational databases, but it offers a horizontal scalability. We'll discuss about horizontal scalability, but it basically means that you are not limited on the storage size. Okay, so that's one of the thing. Another thing is relational databases. We skip that part when we were discussing relational databases, but one of the property of relational databases is that they offer the ACID support. Okay, atomicity, consistency, isolation, and DE's durability. Okay, so that ACID support is offered, strong ACID support is offered by the relational databases. But again, these days they are also offered by a lot of non-relational databases as well. Amazon DynamoDB is one of the use case, I mean one of the example which is offering relational this ACID support, and it's a non-relational. Okay, so there is a very thin line. So again, as I said, right, the database choice would be combination of all these factors on which you decide that which makes sense to me. Cool. Now, coming back to our database selection, we understood what different kind of databases are, how you can make a choice, and what are the different parameters you should consider. Okay, so if we talk about like property onboarding use case, we had one of the requirement of low latency, right? As I said, right, we always have to adhere to our functional requirements and non-functional requirements. So you have to ensure that however you are storing the data, the retrieval has to be faster. Okay, so you have to figure out the access patterns. So what are the access patterns? If we talk about write, add properties, update properties, like are the specific use cases for write. If we talk about read, you want to search the properties based on location. Then you want to fetch the property details such as rooms, facilities, images, reviews, and all those things. You want to fetch the room details. Okay, so these are few of the access patterns, and you have to ensure that whatever database you are choosing, you are able to serve these read use cases in a low latency way. Okay, so as we said, right, we already have relations. We drawn some kind of structure as well. So relational database is a good choice. Okay, and it's also a general recommendation that if you don't have any specific requirement, or like let's say you are not much aware about databases, you can always start with relational databases. Okay, and they will work with most of the use cases. If you have a specific as I said, right, you always have to evaluate and do a trade-off analysis. But if you don't know much, they tend to work in most of the cases. Okay, if you have a specific requirement, then you have to definitely evaluate it, but they will work in most of the use cases, and they are also battle tested software. When I say battle tested software, they have been in the market for a longer period of time. Okay, non-relational databases are pretty new, and like each and every year you see a new offering, so it's hard to say that which will work for me. But these relational databases such as MySQL and Postgres, they are pretty old, and they are battle tested, as in they are already used by a lot of companies at large scale, so you know that they work. Okay, and there is a large community support. So community support definitely helps. You are facing any issues, so we'll get a community support, as in let's say you are posting on some forum, Stack Overflow, you are just asking ChatGPT. Okay, so since there is a lot of information available online, you will get that information quickly, and then you will be able to fix the issues which you are facing. uh, I said that we have that hotel reservation system as a chapter 18 systems and on AWS. So in that chapter, I have also discussed how you can use DynamoDB as a data storage option for this particular use case as well. So, I mean, uh, there will never be a perfect database choice. You will do the evaluation, you have to figure out those parameters, and you can use any database which makes sense to me, makes sense to you for your use case, and then you can leverage it. Okay, now the first part is complete, property onboarding. Now the second thing is property search. You have onboarded the details, you have saved them into the database. Now you have to offer the search. Okay, so this is the basic requirement, that whatever properties are onboarded, you have to search them in the search result. Okay, now we also have to ensure that low latency part. Okay, we are keep on iterating, because like, and this is the important consideration for your interviews as well. Like whenever you are designing the systems, be it a simple system, okay, you always have to iterate on what were the requirements to you, and like whatever decision you are taking, why these requirements make sense, like why this particular decision makes sense, because I had that requirement. Okay, so now let's say you are choosing a particular database. Why that particular, like you took have that particular low latency requirement, and if you choose this database, or if you choose this particular query pattern, then my low latency requirement is there too. Okay, so what are the different ways how you can do it? Okay, so you can query the database, like the data you have onboarded on your system, you can query the database. Okay, yeah. Now we have to have data based on location, right? You don't have that property ID or property name. You generally search based on location. Okay, and your location is not your primary key per se. Okay, so you're trying to scan that data, and scanning entire data. So let's say you have 100 entries. Okay, and the entries are from multiple locations all over India. Cool. Now, but you just need data for Mysore. Cool. So if you want the data for Mysore, you don't want to scan through all 100 entries. There should be some easy way out, binary search kind of thing. Okay, you can directly search in login or some sort of thing. Okay, so that's where your indexes come in picture. Instead of scanning, how you can do better query performance. So index are generally created on columns or combination of columns, and they stored or like keep the data in such a way that you can easily retrieve them based on the location. You will able to figure out it is basically like organize your data in a B-tree format. Cool. So you create an index on top of the column, location column basically, and then you query on based of the location. So you will, instead of scanning the entire table, now you know that from where you have to get that data. Okay, now a few other use cases. Okay, like let's say we have onboarded that, like we have that onboarded data, and then we have created the index on top of location, and then we are querying the data. Now few other use cases. Let's say you have a heavy read load, okay, or let's say there is a same query again and again. If you're trying to get the data for Mysore again and again, so is there some way that I don't have to hit the database, because you are increasing the load on the database? Okay, so one thing is that the general database architecture is that you have, let's say, one machine on which this database software is installed, and then it is storing the data to the disk. Okay, so one general architecture is that you have a, and this is pretty standard for relational databases, that you have one writer instance on which all the write queries goes in, and then you can have multiple read replicas which you can define, which you can use for serving the read queries. Okay, so you can create multiple read replicas for your database to serve those read queries or increase load on your system. Okay, this is the term we often uses replication. Okay, so let's say the data is saved on the writer instance, it is also replicated to the instances. So whenever a query is made, the read query will go to that particular instance, and then the data will be retrieved. And we had a strong consistency requirement, right? So we also have to ensure that whenever a data is written to a writer, it is copied to the read replica in the real time. Okay, the term we use for that is synchronous replication. There is another term which is asynchronous replication, which basically means that you got the right query and then you sent the right query to the read, but you are not ensuring that it is done or not. Basically, it will done in some time, but not in the near real time. Okay, so this is one of the way. Another thing is caching. Okay, you know that you want to retrieve the data for one location again and again. So instead of hitting the disk, what you can do is you can keep the data in memory. Okay, now it's hard to keep the data on machine because you already have that application running and load. So you keep a separate instance for that, and there are a lot of solutions such as Redis, Memcache, Dragonfly DB. Okay, there are a lot of these open source and like cloud provider solutions as well, which you can use for caching. Okay, caching basically is you are storing the data in key value format. So if let's say for particular location is a key, for that location you have list of properties you can get from the database. Okay, so it makes your query faster, and you are also not hitting the database, so it reduces the load on databases. Okay, and we also had a requirement for images, right? So there is another term which is content delivery network. So what you are trying to do here is, let's say for that particular property is very popular in a location, so you are continuously fetching the data from that Amazon S3 again and again, and there is a cost associated to that. Okay, so instead of, and other thing is that if you are passing the image over the internet, it takes more time because it is larger in size. Cool. If it's a small response, then it takes less time to be traveled across the internet. So for those use cases, we try to leverage content delivery network, CDN. Okay, and it basically means it's an extended cache solution, you can say. So it basically says, or like what it achieves is that it caches the location near to the end users. So let's say there is a edge location near to me. Okay, the servers or like the application you're hosted in Mumbai data region, but the CDN is located in Delhi. So instead of retrieving the data from Mumbai, I will get the data from Delhi, so which will be faster for me. Let's say I stay in Jaipur. So depending on your location, the data is retrieved from that nearby edge location. So instead of going to that main location, your query is served from nearby location. So it makes the faster. So these are a few of the things. I suggest that you read more about them, and you will understand like why each of them makes sense in your architecture. Continuing on that, right? We said that we had location as one of the filters, so you created index on top of that, but we could have more filters as well. Let's say I want to run combination of filters. Let's say I want to get all the properties where pets are allowed and they are 5-star rated and there is breakfast included. So the filters can keep on increasing. Now for these kind of use cases, we tend to use something called as databases, which are heavily used for these cases or search use cases is the inverted index ones. Okay, Elasticsearch is pretty popular example. Okay, Lucene is another one. OpenSearch. Okay, they are all built on top of Lucene. So the idea here is that instead of defining those indexes, because it can become hard and the filters can keep on increasing. So it will be easier if you can use or like leverage some solutions such as Elasticsearch. Okay. And this diagram which I have included here, it basically says that you have data in your property details DB, and whenever you have a data in your database, you pass the data to the Elasticsearch, and this schema converter and queue is just to included here. So to give you a simplified version, it basically what it does is there is a different schema for property details DB. Let's say it's a relational database. There is a different schema for Elasticsearch. So how these different schemas are mapped together, they are handled by this schema converter. It could be a software component which takes care of this. Cool. So, and there could be more things to consider in future as well. Let's say some dynamic pricing for properties. The pricing varies depending on how frequent the property is visited. Okay, or let's say there is some festival season. So that is one of the parameter. Room availability is one of the parameter. Property reviews is one of the parameter. Okay, so these are a lot of the things which you have to consider. Okay, and I'm skipping the discussion to go into more depth right now, and I recommend to read that chapter 18. But yeah, the idea is that as and when you are designing the system, there will be a lot of things which you have to figure out, and depending on like scale you are operating on, you can take the decision. Okay, let's say you are just starting out, dynamic pricing don't make sense to you right now. You can implement that at later point of time. Okay, so starting with the design for property booking. So we covered property onboarding, we covered property search. Now the final architecture is property booking. So you have some sorts of search results. You have the property information, you selected rooms and all, you provide the personal details. So this is the basic flow. Okay, you have the booking summary, you book the property. If the payment is needed, you make the payment. If it's not, then you just go ahead and then the booking is confirmed. Okay, so this is the basic flow. Our databases, I will leave that to you to do the similar analysis. If a property is booked, how you will keep the data in your database. Okay, so this again, as I said, right, you will have to do that analysis again and again depending on what your requirements are. Now, one of the critical discussion which comes along in these kind of use cases and it is often asked in interviews as well, like what if there is just a single room on a property and there are multiple customers trying to book it. Okay, and it's pretty famous problem on, let's say, Book My Show as well. Let's say on a movie theater, there is just one seat available and there are multiple customers trying to book it. So how do you handle that behavior? How your system works to handle that behavior. Okay, so now we just consider on the hotels. Okay, now ideally we don't need this implementation. Why? Because that same property can be onboarded onto multiple platforms. Even if you are able to handle that onto your system, it will be hard to know what other system, like what users are doing on other systems. So if there is just one room available, it will be hard to implement that logic for hotel, because as I said, right, that hotel can be onboarded onto multiple systems. So it becomes hard. So what you will need here is you will need some kind of manual input from the owner of the property. Okay, so this is one of the thing. Other thing is generally hotels tend to overbook because they know there will be some cancellations and they don't want to keep the rooms empty. So keeping cancellations in mind, they tend to overbook. Okay, so this is what real life looks like. Okay, but coming back to the interview discussion, if you, let's say, want to do it, how will you handle this behavior? So the idea is to lock the room for a time frame until the booking is not completed. When I say lock the room, it's a software lock. Basically, you might have studied this in operating systems, mutexes, semaphores, and all those things. Okay, so the idea is that you lock that resource. Okay, a lock, if I quickly read out the definition, a lock is a technique used in software engineering to gain access to resource for a specific time frame so that nobody else accesses it for that particular time. Okay, so that room is your resource for that moment, so you lock that room for time being so that it is not used by other customer requests. Basically, not any other customer request can access that information or resource at that point of time. Okay, so there are two ways to achieve this. One is pessimistic locking, another is optimistic locking. On the pessimistic locking front, what you do is you take a lock on read operation, like whenever the operator or like whenever a user or customer is reading that information, and then after that the operation is entirely complete, that the booking is complete, then after the lock is released. In case of optimistic locking, you allow the users to read and update simultaneously, and if there is a conflict which comes in, then the data is not committed. Okay, if we talk about optimistic locking, there are different approaches or implementations which are used for this. For pessimistic locking, like I personally have used Redis as a use case to keep a lock on that particular request and then hold that lock for a time frame until the request is completed. Optimistic locking, I have also used DynamoDB for one of the use case. We heavily use versioning. Let's say you keep one version of that attribute. Now you know that whenever you're trying to read it, you read the version 2, and if you're updating it, you will update it to version 2. At the time of update, it should not be version 3. If it's version 3, then there are some other updates which happen. Now you have to handle that conflicts. Okay, so this is the way you handle these kind of behavior. Now we will quickly talk about deployment. Let me quickly check the time, what the time is. It's 6:12. Okay, we still have time left. So let's quickly talk about the deployment, and then we'll try to end the discussion by 6:40 or something. Okay, so we figured out three components, right? We figured out we have a property onboarding, we have property search, and then we have property booking, and then can be other systems as well. We skipped those systems. There is like one is payment system. Okay, there might be some other system which handles dynamic pricing. Okay, there is other system which handles invoicing. Okay, so there are a lot of platforms which can be components which can be there. So one thing which I wanted to discuss here is there can be two ways of deploying these things. Okay, one is that you club all these deployments or club all these components together and deploy them together. That's what we call as monolith architecture. Okay, another thing is you keep these components and deploy them separately. Okay, let's say you have separate GitHub repo for each of these component, and then you also deploy them. Let's say you create a separate Docker image, then you deploy them separately on a Kubernetes cluster or something, some sort of thing. Okay, so that is referred as microservices. Microservice as in there are multiple services which what do you say, there is a single service which is broken down into different components, and the choice could be that you are broken down depending on the functionality. One is for property onboarding, so you have a separate service for that. One is property search, so you have separate service for that. One is property booking, so you have separate service for that. So these are the two architectures. You will often heard these terms, monolithic and microservices, whenever you have these discussions. Like whenever you are architects and like whenever you join a company, this discussion often comes in. Like whenever there is a new feature or new use case or new requirements comes in, you will figure out if I can extend the functionality of my existing service or do I have to create a new service. Okay, so just to, I mean, the small scale, it makes sense to start with a single service and then later evaluate what we have to do. We have to do that trade-off analysis if it makes sense to break that service to solve our new requirements or meet our FR and NFR. So this is the general flow which I want to talk about, is that whenever you are, so system design in one aspect, right? Now another aspect of system design is you are deploying those things. Okay, so what we're trying to do is we will start from the basic and then we will try to take it to some next level. Okay, so we will start from the basic. So let's say you have a machine, you have a EC2 server from Amazon. Okay, or you have rented out any virtual machine, like however you are hosting your application, and then you are deploying all the components. Okay, and how will the end users talk with this machine? Via its IP address. So every machine has a separate, like a unique IP address. Your laptop also has a IP address, right? That's how it is uniquely identified. Okay, so it has an IP address, and whenever our users are requesting or like hitting that machine, they will hit to this IP address that I want to get this information. Okay, on this IP address, some port is open, and that on particular port application is running. So you will hit that particular address to get the information, let's say of property search. Now, what if this machine is replaced? If this machine is replaced, then you will have a new IP address. That is a problem, right? How it's problem? Because now you have to give that new IP address to the customers, that that previous machine is replaced, please use this new IP address. This is not a good customer experience. Okay, so what we tend to do is we get a static IP address. In case of EC2 or like Amazon, elastic IP is one of the concept, or it's one of the feature which is being offered. So even if the machine is replaced, that same IP is attached to that machine. So for users, there will always be a single IP address. This Route 53 component will come in next slide. But yeah, the idea is that user is hitting that same IP address again and again. Now, let's say, what if this machine is not able to support the increasing load? We said that one of our requirement is scalability. We want to support the ever increasing load. So how will you do it? Okay, so let's say my limit is breached for this machine. This machine is not performing well. So in that case, you will need a bigger machine with higher RAM or like higher resource, higher CPU utilization. So whatever bottleneck you are facing, you will get a bigger machine. Okay, this is called as vertical scaling. Vertical scaling basically means you have a machine with some features, and then you need more extra resources, so you buy a bigger machine. So that is what we call as vertical scaling. There is one issue though. The issue is that whenever you are migrating from that smaller machine to bigger machine, when you are deploying that application, there is some downtime associated. Okay, and the idea would be that, okay, let's take a step back, that you have vertically scaled to a limit, but you also have to figure out like how much bigger you can go. Okay, at some point you will reach a limit. It's not that you will keep on increasing the resources, and there is not a limit. Then you will reach a limit where you will not be able to get a more bigger machine. Now in that case, what you will require is you will need more machines. So instead of just single machine serving all the requests, what you can do is you can have multiple machines which you have to serve those requests. So customers can hit any one of these machines to get the responses. Okay, so this is what we call as horizontal scaling. Okay, vertical scaling is getting a bigger machine. Horizontal scaling is instead of one machine, you have multiple machines. Okay, when I say machine, you just treat it as a server or like whatever term you are using. Okay, so I'm pretty habitual with the machine word. Okay, so and how will the users interact with the system? Now, it was easy earlier, right? It was easy earlier because I had a single machine. So I have provided, let's say, IP address. But if a single machine is receiving too much load, then you have to have multiple machines. Okay. Now, if you have multiple machines, it will be hard to share those different IP addresses. And how will customers know which machines I have to hit? Okay. And let's say one machine is more heavily used by more customers. Or let's say you have given one machine IP address to Rajasthan users, another machine to Maharashtra users, right? But let's say Maharashtra people are using more, so that one particular machine will have more overload. So in these kind of scenarios, we introduce a component called load balancer. Now the responsibility of load balancer is that it will balance the load between these different machines. So the customers will hit the load balancer. Load balancer will figure out which machines I have to hit, or on which machine the load is minimal. And there are different load balancing techniques and strategies which are being used by load balancer, and there are different kind of load balancers as well. But skipping those details, the idea is pretty simple, that there are multiple machines, there is load balancer in front of them, and then the customers have a single IP address of load balancer to hit it. Okay, so the load balancer has the responsibility of balancing this traffic between these different machines. Now, one thing here is that it's hard for users to remember an IP address, right? Can we offer a more friendly name? One example is that will you search via latitude and longitude in Google Maps instead of location? Okay, searching via location name is easy. You enter a particular location name and then you get the details. Okay, so the term here, which is we try to create a easy name for it, English name for it, the IP address, which can be mapped to your domain. Okay, we call it DNS, domain name system. So you have a particular domain for your system, or like for your IP address. So the customers will hit this particular domain, and this will be redirected to that particular IP address of your load balancer. So this is one of the Example is msdeepsingh.com. This is my personal website. So whenever you hit this domain, it will be converted to the IP address, and then it will reach to that particular machine where this website is deployed. So right now, this architecture which you see on your screen, you have your users. The Route 53 is a AWS service which is helpful in managing these DNS and all those things. So it will route the request, figure out that IP address, and then the request will be routed to the load balancer. Then the load balancer request will be routed to a specific EC2 machine or EC2 instance. And then I have also shown the databases here. In, let's say you have multiple databases entries we discussed, right? You have multiple read replicas. Okay, so this is one of the this is how you scale as you move on. Now this is the bigger picture. Like I didn't go I didn't go through step by step, keeping the timing we have. So this is one of the architecture which could be used for property booking architecture. This is what it looks like on AWS components. So you might not be aware of the components. It's okay. Okay, now you don't have to worry about it. I will just try to quickly go through the details, and you will understand the things. So the users will hit Route 53. Why do we need Route 53? To get that IP address. Okay. Now, once you have the IP address, you will also need some kind of authentication, right? So Cognito is one of the service which you can use to manage the authentication and authorization of services. API Gateway is platform similar to load balancer, not exactly as load balancer, but it can be used to implement other things. Let's say you want to implement rate limiting or throttling. Okay, rate limiting basically, or like figuring out if some requests are not from proper host. Okay, there is some hacking event. Okay, so you can integrate multiple services with the API gateway and then use those features along with. Okay, you have created your simple APIs. Let's say booking a room is a one API. So your users will hit that API from your front end, and that will land to here. AWS Lambda is basically a serverless component. It is a function as a service where you define your code to handle that booking behavior. Okay, you can replace it with a machine where your code is hosted. Okay, this is your early architecture which you can use. Okay, now once you hit that, you will get all the details. Okay, you will get the property pricing, you will initiate the booking, how the booking is initiated, you will figure out what the details are there, and then finally the data is saved to the database. Okay, this SNS and all these things are used for sending out the event to the customers as well as the owners of the property. Okay, so this is one of the high level architecture. Just to avoid any further confusion, I will move on to next slide. But yeah, I will suggest you to read through the book of this chapter, and you will get some more insights. But stick to the previous architecture which we discussed earlier, right? You have the code deploy on your machine, and then from there you can serve your end users and the scaling behavior we discussed, like starting from one user or like one machine, and then how you scale to more machines to serve your increasing scale. Now we have our early architecture in place, right? Now, how do you scale further? And this is the important discussion for interviews as well, or like if you are working in a startup or a big company, it applies everywhere. What you have to do is you have to keep on evaluating the architecture again and again from time to time to identify bottlenecks. So let's say I have that low latency requirement. Now, if the scale is increased, that low latency requirement is not adhered. So again, you will have to evaluate, can you improve the architecture? Okay, so that will be a continuous process. Another thing is data archival. Okay, so let's say if a property was onboarded, now that property is delisted, so you want that property is of no use to your database, right? It is just consuming that extra step. Okay, or your, let's say, older bookings, the bookings are already completed. So instead of keeping them in your main database, you can archive the database. Archiving as in move it to some of the archival solutions. There are a lot of solutions which are available so that the cost is reduced. Observability as in you want to keep the metrics from day one. Metrics as in like how your system is working. One simple example could be how many bookings were done. Okay, so you have those metrics in place. Or let's say if something goes wrong, you have those logs in place, like what went wrong. You have those exceptions captured in your system, which you can figure out like what went wrong for this particular customer. Okay. Another thing is you want to move away from fully managed service as you scale. I will again skip this point, not much relevant. And one important thing here is like whatever architecture you are designing, there will always be failure points. Okay. So you will have to figure out how will you handle that failure behavior. Okay. Then it's as I said, right, it's pretty hard to gain that 100% availability. It's pretty hard, and you will not see the like very useful systems which are there in the market. They also don't offer that 100% availability, so there will be always be failure points. So you have to identify those failure points, and you have to figure out how can you reduce that blast radius so that it impacts very less set of customers. Scaling more, let's say you are adding new features, you have more implementations, and you have like new requirements coming in. So like some of the examples could be exploring point of interest for guests. Let's say I'm staying in Jaipur, so what are the other places I can visit there? Dynamic pricing, we already discussed, could be one of the requirement. There could be more integrations in the platform. Let's say I want to support flights, cabs, experiences, services, etc. Okay. So, and there can be increasing team size as the company grows. There are more and more people. So instead of single service, let's say now you can break it the system. And started like we started off with just the 3 components, right? So now we can have multiple components in place. Cool. So I will summarize the discussion, whatever we discussed right now. So I started off the discussion like after the system design definition, we discussed that there will always be trade-offs. There will be never be a perfect architecture. So you have to always keep in mind like how simple architecture can be designed. Okay, how easy it is to understand, how easy it is to reduce that on-call behavior, on-call load. Okay, operational overhead should be minimal. Okay, so you don't have to think if some architecture is complex or like there are a lot of components which you see in the diagram, it should be good. Okay, it doesn't mean if it's a complex architecture then it's a scalable architecture. So you always have to keep that in mind. You have to iterate over time. Okay, whenever you are designing a system, you will always iterate, as in like you had some requirements and then you evaluate again. If there is some more features to be supported, then you evaluate again how you can support it. MVP to MVP basically means you are scaling from minimal viable product to most valuable product. Okay, so this is the software engineering journey from day zero to day end, from supporting one customer to supporting millions of customers. Observability from day one we already discussed. It's pretty important that how your system is behaving. You have those proper metrics and logs in place. Again, I think I'm reiterating on this step that there is no such thing as future-proof architecture. Okay, you can plan for ahead, but I mean, things are bound to change. There will be new things which will come in future which you have not prepared for. Okay, so your architecture or like whatever system design you are doing is bound to change. New things come, your architecture will evolve. So you, whenever you are designing system, you have to keep that in mind. These are the links where you can connect with me, and these are the QR codes which you can scan. One is for my YouTube channel, other is for the book. The website link where you can get all the information about the book and all those things. I open the stage for questions and I will stop sharing my screen. If you have any questions, let me know. We have 30 minutes. We ended on time. So that was my idea, that we end the discussion by 6:30 and then we have questions from the audience. So yeah, let's get started.
Uh, Hello, sir. Uh, can you give few insights or just briefly explain what was Redis? Like, what is it exactly?
Yeah, can you repeat?
Uh, like you mentioned, while explaining, you had mentioned something about Redis, right? So, what is it exactly?
So we discussed uh, caching strategies, right? So if you want to make your queries faster, what you want to do is you want to keep the data in memory. Okay, It's as simple as, let's say, if you are retrieving the data from disk, it is slower as compared to whenever you are keeping the data in memory. Okay, so that's what Redis is trying to do. In case of most of these databases, the data is kept on disk, but in case of these in-memory data stores, the data is kept in memory. So Redis is one of that example. It's basically your database only. Okay, it's an in-memory database. It's a key value database. So for that particular key, you have that information stored. So let's say for your key is location, and that against that location you have all these properties listed. So whenever you are trying to get that information, you can directly get from there. So yeah, it's a database choice and an in-memory database to make our queries faster.
Okay, sir. Thank you.
Let me see if there is anything in the chat as well. Yeah, there is nothing. Do we have any more questions? And if there is nothing around system design, you can always ask, general questions as well. It's fine.
Sir,
Uh,
um,
yeah.
how deep should we go into scalability and consistency models during interviews?
See, interviews, it basically depends. I mean, interview is a 1 hour discussion, right? And you have to keep your requirement discussions under 10 minutes. So it will be dependent on interview. So you have to keep on discussing with the interview what's the correct expectations. Now, if you talk about consistency, right? It could be dependent on the use case which you are having. Okay, let's say for some use cases strong consistency is required. Now let's say if interview wants to get into more details, generally definitions are not asked, but if someone asks like what is strong consistency, then you have to explore more, like not like strong consistency, what is eventual consistency and all those things. So this is the idea. I mean, it's pretty much dependent on interviewer and your day.
Thank you, sir.
There is one question from the in the chat. What's the fallback if third-party services, example payment auth, fail during onboarding? Okay, so see, it depends. Now, if you are, let's say, just starting out, okay, if you're just starting out, you will leverage these third-party services, okay, and you tend to use a single service only, okay, but and there are generally no fallbacks in that case because you are only having that single service or single third-party vendor which handles this payment. But as you scale, right? Let's say I was part of my earlier company. Now we were integrated with single payment gateway, but as we scale, we were exploring that we should have multiple payment gateway integrations. So let's say if one of the payment gateway is not performing, we figure out beforehand like what is the success rate of these payments. Okay, so depending on the success rate, instead of routing the request to that failing one, you will route the request to another one. So the idea will be that you have that fallback mechanism in place in case of payment or auth. If one system or third party system is not working, then you have that replacement in place. So that's one mechanism. But if you're just starting out, the idea is that you have that only single option. But if something goes wrong, you have pretty good communication channel set up so that you can call that third party vendor and then ask them to fix that quickly. That's the idea. Okay, the next question is storing images in S3 and keeping the reference in the database. Could you elaborate in how that integration works in practice and how to handle consistency between them? Okay, so when I say keep a reference in S3, right? And keep a reference in database. So what's the idea here is, so I will talk about a simple example. Okay, so whenever you are uploading the images, okay, there is a separate window where you upload the images. Okay, you have that, let's say, upload images, you pick up those images from your desktop and then you upload those. Once the upload is done, so it's a separate flow altogether. Once you upload the images, you will receive the response of URLs. You will receive URLs of those objects in the response. Now you use those URLs in a request when you are actually saving more details. Now that at this point of time, those URLs are saved to your database. So this is how you keep that reference. And as far as consistency is concerned, the data will always be present in S3 and then you are saving to database, right? You are not doing that in a way that like first is stored into database and then it is, I think your questions comes around that if you are trying to save it together into both of them, how will you ensure if one fails? So they are not parallel operations, they are sequential operations. Generally how it works is you first upload images, you get the URLs and then you pass the URLs in the second API call, and in that case those URLs are saved along with other details in your relational database or non-relational database of your choice. I hope it answers. uh, Next question is, how do companies choose between CAP in real world? Okay. In real world, as I said, right, P is not optional. P is always there. P is partition tolerance. So it will always be there. You have to choose from consistency and availability. Okay. Now, when I say consistency and availability, this theorem theoretically states that if you want to achieve 100% availability, then you can't have 100% consistency. Okay. So, but what if anyway you are not able to ensure that, right, 100% availability? So you can get a middle path here, that you have 99 point this particular availability and then you have, let's say, strong consistency, or for some use cases, let's say you have eventual consistency, and then for that use case also you have that percentage of availability. So I mean, it's hard to achieve those theoretical values given the real world scenarios. For the general role of data engineer, how important system design in interviews? See, I personally am not much aware of how system design is asked, but the aspect of system design changes. I mean, like what I know personally is, like in, let's say, software engineering interviews, you are asked to architect these systems. But in case of data engineering, you will be asked to architect data pipelines. So that's the system for them. Okay. So the aspect of the system change. System design doesn't mean software engineering system design. It could be anything. So for the similar question applies to DevOps as well. Like how will you architect the systems or deployment per se? Okay, there are different strategies. Will you use Kubernetes? Will you use Lambda, which I saw on? Okay, or let's say some other EC2 machine. Okay, so that's the trade-off analysis you are doing for DevOps interview. Okay, so that system design aspect applies to every one of them. It's just that what is being asked in change for the different roles you are applying. So for data engineering, I think it would be pretty much around data pipelines and how you create those data pipelines at scale, all those things. But again, I haven't worked in this domain. So yeah, but yeah, this is my understanding as I have interacted with the guys. Yes, Pujita.
Good evening, sir. So could you please explain like how team familiarity would influence the database choice?
So can you repeat how team?
How the team familiarity would influence the database that we choose or the database choice?
Familiarity. Okay, the expertise one. See, that's the important angle. Okay, so one is the team familiarity, other thing is what company is already using. Okay, so if a company is already invested a lot of effort in setting up the MySQL cluster, now if you say that if I don't want to use MySQL, I want to use some other database, so you have to justify your case, because that comes with extra overhead of setup and all those maintenance and all those things. So if a team is already familiar, if the company is already familiar with some of the technology, then they tend to use that same. And then if there is some like a unique requirement, then definitely they will evaluate again to the new requirement. But as long as a particular database meets the choice which a company is already using, which a team is already using, then they will use that only. So yeah, it's pretty much important.
Okay, thank you, sir.
Oh. Yes, Anusha.
Hi, sir. In the architecture that we saw before, there was AWS Lambda function between the between the API gateway and pricing, payment, billing systems, right? So, are they just routing the request, or do they perform the business logic and orchestration between the services as well, sir? Can you say about it a bit?
See, I'm not sure how much familiar you are with the AWS components and as well, and that's why I didn't go into much depth of that. But how Lambda works is, Lambda is your, like, you do, let's say, so one of the aspect we discussed was operational overhead, right? So in case of these machines, you have to manage those. But in case of Lambda, what you have is you have that runtime environment available. So let's say you want to create that Python class. Okay. Now you, let's say you just have that Python class, and how can you directly run that code? It's your, let's say, online editor. Okay. So you open the online editor, you wrote the code, and then you executed it. That's how the Lambda works. You directly paste your functions. So Lambda is your function as a service. We often use the term serverless. Serverless as in you don't have to manage the servers. There are definitely servers which are underlying, but you don't have to manage them by your own. Okay. So the idea here is there will be business logic which you can keep as part of those functions. Okay. So you receive the request on API gateway. It is routed to the particular Lambda depending on the API where you have your business logic written. You do some that business logic analysis, or like whatever logic you have. Once the logic evaluation is done, then you finally save the data to the database.
Okay,
I
sir.
hope it answered. Okay.
Yeah, thank you, sir.
Another question is, how can we prepare ourselves to understand large systems quickly as freshers? Okay, so as freshers, I mean, see it, like what I have seen generally is the heavy focus is generally on coding, not on large systems basically. Okay, large systems come in picture when you are moving above the ladder. But let's say you want to understand out of curiosity, like how you want to understand. So I will say that you start from the engineering blogs. Okay. Uh, there are a lot of companies, okay, which publishes engineering blogs. So start from there, try to read. Okay. If you open any of the engineering blog of any company, try to read it, how that particular feature is implemented. Let's say you are using Netflix, right? So if you use Netflix, just search through the engineering blogs. You will find that if I'm using that particular feature, how it is implemented internally. And as part of that engineering blog, you will find a lot of details, and which you will not understand because you have not worked on them personally, right? So you will figure out a lot of details which you don't understand. Now you can use those details to search again on internet, like how these works. Okay, so this is the, I mean, the journey which you can follow, that you start from the basics, you keep on reading, and then you figure out these things. Okay, you will figure out these terms. Let's say load balancer, API gateway, Lambda is the term which we used. Okay, SNS. So these are the AWS services which are there. In general terms as well, caching as a use case, Redis. So how these systems work internally. Okay, so if you have curiosity enough, you can read about it, and after that what you can do is, if like for these databases per se, right, these are some solutions which you can directly deploy on your personal laptop. So you can do the deployment and then create some sort of personal project, so you'll understand more around that. So this is the basic approach you can take. Yeah. Another question is, how would interviews look for a system design interview? What would interviews look for in a system design interview answer? So again, this depends on the level, on which level you are preparing for. If it's for let's say just for freshers, it's pretty standard, as in they focus on some low level details, as in some design patterns, and so there is less discussion, or like there is not heavy discussion around scaling the architecture. There can be basic discussion around load balancer and like networking protocols or database choices basically, right? And you also study that as part of college. Okay, so there can be discussions around database choices, like which database will you use, how, why will you use it. Okay, so these are the discussions. So on the freshers, this is the way. But as you, I mean, go beyond that, the answer, there is no standard format. Okay, but if I give you a general flow of things, like whatever flow we took today, that you understand the requirements, you understand functional owner, functional requirement, you understand the scale, then you start with the design. When you start with the design, you figure out some internal details of it. Okay, as part of the design, you figure out, let's say, database choices, what kind of APIs which you will have, what kind of networking protocols which you will have, or let's say what kind of services which you will create. You figure out the components, will those components will be deployed together or separately. Okay, And then finally you create that architecture, then you figure out what are the failure points in which can occur in your system, then you try to fix that. Okay, so the idea would be that you have that journey in the place, and you keep that in mind, that let's say I will discuss for 10 minutes, I will discuss these requirements. After that I will discuss the expectations from the system, like how the initial design would look like, what are some edge cases which you can identify, what are some of the bottlenecks which could occur. So you identify those, you fix those along the way, and then you can keep on getting the feedback from the interviewer. So that's the key. Systems and interviews are just a discussion. Okay, how you will do in the real job. This is not a one way, so you keep on discussing with the interviewer. I mean, what are the requirements, if it's meeting the use case, why you, if you, let's say you are saying that MySQL makes sense, so you should be able to justify why that's the case. Okay, so that's the general idea. Okay, do we have any more questions? Yeah, I think we should be good.
Sir, I have a question.
Okay.
Sir, in most of the legacy systems, there will be no proper system design. If any of the company thinks to redesign its system design based on its requirement, is it possible for it to transform the old legacy system with a new system design, or should it scrap it, the old one, and do the new one from the beginning?
I mean, so as I understand your question, you basically you are trying to understand if system is re-architected. Will you scrape off the old design, or like will you iterate over it?
Yes, sir.
Okay, so see, it depends. I mean, like whenever new requirements come in, you will figure out if the existing system makes sense or not. If it does, or like if you can integrate that functionality in itself, then you can. Okay, let's say your query performance is low. Okay, now you will try to figure out if you can fix those queries. Okay, if you can, then you will try to do it. The idea would be that you try to do it in the existing system as long as possible. If you arrive at a point that your existing system can't scale further, so that's the point where you like architect a new system. Because I mean, like whenever you are working in a company, the idea is always that how you can reduce the effort. Okay, so migrating to a new system brings lot of new effort. You have to migrate those customers to a new system, you have to migrate that data. Okay, so there is a lot of migration effort that comes in. So that's the last thing we try to do. If we identify that existing system can't scale further, and there are a lot of bottlenecks, and the new requirements can't be supported in the existing system, then we architect a new system. But as long as we say that our current system can work, and you can include the features in the existing system only, and then you can also adhere to your requirements, then yeah, that's the way to go.
Okay. Thank you. All right. So with that, we'll go ahead and wrap up today's session. Thank you so much, sir, for such a truly insightful and engaging talk. The way you explain system design with practical content and clarity really helped us understand not just what it is, but why it matters. For many of us, system design felt like a big complex topic, but after today's session, we all have a much clearer understanding of how systems are actually built and scaled in real world. It's been a great learning experience, and we're really grateful you took the time to share your knowledge with us. And a big thank you to all the participants who joined us this evening. Your presence and enthusiasm made this event even more meaningful. We hope to stay connected and look forward to hosting more such sessions in future. Thank you so much.
Yeah, thanks everyone, have a good day. Bye bye.
Bye, sir. Thank you so much.